Hey guys, this is Chris David. Just getting together with you guys for the CIT 260 final presentation. Been a long semester. Been a lot of late nights and head banging, trying to understand everything as we've gone through all of the lessons. But here is my presentation. I'll go ahead and leave both sides of the screen up. I have my presentation on the one side with the outline. And as we go through, I'll show you some code and we'll discuss some of the topics here. Let's go ahead and get started. We're going to first discuss a static class variable and non-static class instance variables. The main difference between these two is static's referring to properties being static, unable to be changed. They're set. There can be certain properties. And non-static is a variable that allows the details to be changed or adjusted. They can only be referenced if you have an instance of the class created. The static cannot call a non-static, and a non-static cannot call a static variable. They're separate there. There's a workaround, but you can't call them directly. Two examples I have in my code are my player object and my game character object. I'll go ahead and show you these ones. See, it's in a static setting here, player's name. And that's mostly because once the player's name is set, I don't want it to be able to change. That's the set player's name. Down here, you'll get the player's name for the getter and setters, and you'll set it. So that's an example of static. I'll go over to our game character. You'll actually be able to see these different variables here that are meant to be changed and adjusted throughout. We have the game character's health and their location on the map through the coordinates and the direction that they're heading in the game. These things aren't static. These are going to be just instant variables, which can be called and changed and modified throughout the game here. So we got this game character. It's going to go ahead and set the beginning of the game stats for the character, 100% health, and so on. It's going to return that health. Now, that's how the static and non-static work. Go ahead and go to the next page of my presentation here, discussing array lists, and enum. These are three very useful tools. I do not have just an array in my code. I do have an array list and an enum. Now, I will explain though each one of these here. An array is a fixed length, cannot be changed after it's created. I do have an example here, an int array, and equals new int, setting it at 20 elements within that array. Now, with the 20 elements there, the next line, I have int array equals, and now I'm setting each one of those elements. You'll actually go out, I have it listed, 5, 10, 15, 20, 25. That's only 5 of the 20 elements, hence the ... And that will just continue out until each one of the array elements is assigned a value. Now, array list is a list that can dynamically change its size or resize throughout the game. Changes as the data changes. And then an enum is a class list of constants that are predefined. These values cannot be changed. They're also fixed. To give you two examples of those, actually I have it in my map. I have a location array list. It's actually a colon from my view map view page, in which is created in this section of my code, this block of code. So as a player wants to view the map after the game started, it will go ahead and initialize through this for loop. And this for loop will actually go ahead and it'll assign a certain amount of length and depth to the game, the rows, the column rows. And after it's created that and assigned the position of the player to the location, it will go ahead and actually assign it to this location array, which flips back here, which is called on my map page. So that is how also in the rubric it discusses display for statement and how it's called in an array list, and that is how that occurs here. Goes through there, it executes the creation of the map, and prints it out for the player to see. So on enum, though, let's go over to my scene page here. I really like enums. They're unique. I didn't know anything about them until this class. But in this scene type page, I have different scenes that I've created. And because the enum is a class list that is full of constants, predefined, doesn't change, what happens is I have this forest here. And in the enum list, I'm able to go ahead and actually set a description for my my starting scene. So new scene, we'll go ahead and assign this description over to the starting scene, and then it goes just throughout the different scenes that I have. I have a forest scene, I have a hilltop scene, different descriptions for each. So that's what I've done there with the array list and enums. The next page here is runtime errors. Now, runtime errors use a try and catch statement. These help regulate the errors through just proper hierarchy of the code, and informs the user in a custom message. Example I have here is in my exceptions page here. I have this block of code that creates the exceptions for any errors that happen. This one particularly is spelled out for a player that's trying to move off the map. We don't want the player to be able to put in that they want to move left when they're the farthest left corner of the map, because then nothing would happen. Nothing's assigned over there. It would break the game. We have an exception that will catch that. It will not allow that to execute and display the message to the user saying you're trying to move off the map. You cannot do that. This is executed or called in, or it uses, the exception, my exceptions class inside the view map view that we were just in for the for loop. But down below, this is how it does execute here in the move on map method. Got try and catch, as I explained earlier. So it's going to go ahead and grab the move on map details and properties, and I'll go ahead and catch any errors if there are any. So another thing I want to go over is the character stream versus byte stream. So character stream, we have it's most popularly used since they handle any format the data is stored in, and this helps cause less errors, allows the program to run smoother. It's also written out to an external file. and I'll show you more about the text files in a moment. The byte stream or bit stream is used to read one bit binary data at a time, typically used when you want to read or write binary data. So typically you want to use the character stream because it's more versatile, allows less errors, and runs smoother. So an example of this is in my apply inventory view. We'll jump over there in the code. Apply inventory view has an apply inventory.text in which calls in the super here, it calls for this text. I'll pull up this text to show you. This is stored in with all my other text files in the game data. Essentially, it just stores this. It is able to display it when called. Enter ID of item to apply. Please enter your selection. So that's stored in a text file, and have several of those, as you've seen, being applied inside the game. So another thing we wanted to go over is writing out to an external file. Actually, I have this happening in the game.java. So we got map text, that's setting the map as resources. As you go through the game and resources are being found and used on the map, it goes ahead and sets the map details to that. So that's one way of being able to do that. And like I said, it really helps with simplifying and making the game a lot smoother and limiting errors that are being used. So that really covers all the rubric, except for actually displaying the game that we've created this semester. I'll go ahead and pop this up here so we can take a look at it. I'll run it. Take just a moment. So beginning of my game, I have a little detail here for the user to read, and then they can go ahead and set their name. Go ahead and type my name, Christopher. Now, one thing in the game, I haven't been able to implement everything. Ran out of time. I'm going to continue, so I have until midnight tonight to resubmit items for changes on my code. But as far as this presentation goes, go ahead and we can start a new game, and we can also view the map. When you view the map, you'll see the game character's health is 100, coordinates 0, 0, and then you have us at the top left of the map. We can actually go ahead and move. We can move north, west, south, east, explore each scene. If I remember right, that one still isn't fully implemented, but let's go ahead and we'll move west. Let's move west with the right character there, and to show you the error that you get that I was describing from the runtime error. So you try to move off the map, you cannot do that. So let's choose something that actually is feasible. We'll move south. It gives us a new coordinate, 0, 1. Health 90. Not 100% sure why yet. I'll have to look into that some more, see why that is. So we didn't fight in a beast or anything, but it does move us down on the map there. And if I try to explore, it does give us a little description of what happened here. You got stung by a jellyfish while wading through the stream. S for stream. And it also goes ahead and makes this -10. Jellyfish was 100, -100. At this point, it should kicks out saying we lost. But just so you can see the purpose of the game, I wanted to demonstrate that. We'll go back to view here and try to view health here, and it's just not fully implemented. We try to construct a raft. It does pull up description here telling us what we need still. We still have not found all the items to be able to leave Insanity Island. But anyways, that's really all the game that I have to show you today. Got properties of the game that are working just fine and others that aren't fully executed, but appreciate the opportunity to be able to go over this with you so you can see our progress throughout the semester. Anyways, take care for now, and thanks for listening.